Hello, I am Shane Brinkman Davis Della Moore, and this is Code and Optimism, a show where I explore how to solve problems faster with software. So here I am, still recording from Spain, trying different audio setups. I'm just in the hotel room here, and currently I'm in Bilbao, which is another lovely city to explore. Loving it here, highly recommended. I want to dive into the topic today, which is continuing last week's topic of refactoring. So this is Refactoring is Life Part 2, possibly of more to come. Today's focus is how to plan and manage a refactor. I think there's going to be one more topic, something around how do you build your code to be easier to refactor. I think that's a very important topic, and perhaps the most important of all, because I think there is an unbounded amount of improvement in how well you can make your code easy to refactor. And that is going to, perhaps above anything, escalate your ability to deliver software faster. And in fact, a little teaser there, my belief is there's only one definition of code quality. There's only one thing that matters for code quality, and that is refactorability. The quality of your code equals how easy it is to refactor. That's what code quality means. But that is a topic for another show. Today we're going to focus on some very pragmatic ideas I've gathered together, which I hope you find useful. So we're going to talk about how to plan your refactor and how to manage your refactor. So the initial part of planning your refactor, this all kind of blurs together because how you're going to manage it is going to affect how you're going to plan it back and forth. But we're going to kind of start at the planning end and kind of end up on the managing end. So planning your refactor, the first part is just discovering that you have a refactor that you need to do, and just even identifying that there's a potential way to do things better, identifying that it is a refactor, which say it's in that range of not trivial to do, but something you can do without changing the external interface of your product. So it's contained within that bounds of what I've described in the last episode about refactoring. And I would say the first place to start, and this is kind of a before you even plan a refactor, how you keep an eye out for refactoring opportunities. And as you're working with your code base, you and your team, whoever is touching the code, I encourage you collectively to make notes as you're working on the code anytime something seems less than optimal. Anytime you are editing the code, making changes, and you're like, feels harder than it feels like it should be. Maybe it's harder than if you'd start from scratch. Maybe it is you have to touch a whole bunch of files when this is conceptually, always a good metric is how much English prose would it take for you to describe the refactor to a peer in enough detail for them to do it exactly, or to do it, to a certain set of requirements, versus how much editing does it take of your code in order to achieve that refactor. And in a efficient language, in a ideal world, maybe that's ideal world, but I do think that's good to compare those things. And they should be kind of similar. Like the amount of English prose it takes to describe what you need to change should be kind of the amount of information you should have to be able to embed into your code to achieve that change in the ideal world. And if it takes more than that, and you have to sort of qualify, your language might be more verbose than English in general, or whatever your native speaking language is. So you have to kind of be able to compare, but say, compared to this problem over here where I could describe it in a couple paragraphs and it took a couple hours to do, and versus this problem over here where I could describe it also in a couple paragraphs, but it took 3 days to do. That's a good baseline for getting a sense of how complicated your refactor is. So whenever you're doing these changes and they seem harder than they should, that is a point where I would throw some notes into a note log. Now, I've also just done this for myself. I just use my note app. My current note app of choice is Bear for the iOS, the Apple world, because it lets me write in Markdown, which is very convenient as a coder. And it has some great organizational tools like path tags and so forth. So little plug for Bear. no association, no affiliation. I think it's a useful tool. And I use this keyword called shortcomings. So whenever either in my own code or when I'm using other apps, when I notice something that isn't as good as I think it should be, I'll just throw a shortcomings entry attached to whatever that item is in my notes. But I think this is most important for you on your own code base to build up an understanding of what needs to happen. And quick tip, quick history, quick scenario, let's call it that. This is how the programming language CaffeineScript that I wrote came to be. Is I was using CoffeeScript. I love CoffeeScript. I loved using it. But it kept having these shortcomings, these ways where I think it should have been a bit better than it was. And I started taking notes on them. And by the time I had about 200 shortcomings in my notes file, in my notes app, at that point, I had crystallized on what CaffeineScript should really be. Like, it had become something that was pretty well defined. And it was a big change. It wasn't small, so I couldn't really go to the CoffeeScript community and say, all right, let's go this direction. It was just way too big of a change. It's going to need to go from scratch. And so that ended up being more than a refactor. That's a reproductization. That is a full rewrite, obviously. But the same thing applies to refactors. Take notes along the way, make a shortcomings log. It's really effective, and as you get better at noticing things, quickly adjusting a shortcomings down really fast and just getting back to work, I found it actually, contrary to being interrupting my work, actually makes my work go more smoothly, because it gets that idea of, oh, this is irritating because it's not working well, out of my brain into my log quickly, and then I can keep thinking about the actual problem I'm working on, rather than continue to be irritated or frustrated by something being slow or awkward to use. So that'll help you formulate your thoughts leading into refactoring. So now let's assume you've identified an opportunity for refactoring and you've got some thoughts on what the problem is, at least. So now I want to give you a little bit of a structure for thinking about the refactor. And the first most important thing is you should always start with a greenfield approach. Say, if I was to write this from scratch today, ignoring everything that's in the code base, ignoring all the history of the product, but just knowing what the current requirements and the current known coming up requirements are for the product, how would I write this from scratch? Do a high-level design around that first, because that is really where you should be going to. You should always go to what you think is the current best solution, given your understanding. And that may not be practical. We'll get to that in a minute. It may not be practical to achieve that, but you should use that as the target, and then only if it's not practical, find the closest to that target you can get that is practical. So high-level design on this, don't spend a lot of time on it. I think when you get good at refactoring, you can kind of just do this in your head. This exercise just kind of happens naturally. But I highly encourage you, if you're not feeling confident or if you just don't have clarity in your head, to go through a planning process. I would suggest to not make it too complicated. I would think a one-page diagram with at most 10 nodes and lines connecting things to sort of explain how the new system should be organized. Anything more detailed is overkill. If you need to present this to other people to convince them, maybe it turns into a 10-slide slide deck. Again, you can maybe have one that's a diagram and 10 other slides to sort of explain the various nodes. Anything more complicated, that's overkill at this point, and that might feel overkill for a lot of things. I do a lot of my refactors fairly instinctually at this point, but I think it's a good tool, particularly if you're working with a team and trying to plan a refactor together and try to have the whole team be on the same page of what's going to happen in this refactor. So come up with a plan, make sure it's greenfield, make sure that you're ignoring the current code base. That's the most important thing, is don't start with what is going to be easy to do in the current code base. Start with what would we do if we did from scratch, if we did a clean slate. Once you have that, then go back to the current code base and figure out what does it take to get from here to there. Now you have a destination and you have a source, and now it's just pathing in a certain sense. Now, this is really pretty specific to your problem, so I can't go into too much details here, I think. You need to figure out what the path is, and you have to figure out whether or not it's practical. I mean, you can get from here to anywhere. You can get to that ideal thing from here, but if it looks more like a complete rewrite to get to there versus how can we incrementally change the current code to get from here to there, If it's a complete rewrite, you might be switching into that realm, like I did with coffee script and caffeine script, of complete rewrite, which is say if we're going to do this big of a change, we might as well break external compatibility and call this a new major version, because we think it's worth doing. It's a big deal. But if you are not going to break external compatibility, if it's a refactor, and either if you can't quite get to where you want to go, that might be okay. You might be able to achieve most of your goals with something that's adjacent. You might reassess where your target is for what is achievable within a reasonable amount of time, and that's okay. But you should always set the gold standard first and measure everything against that gold standard. All right, moving along. Incremental. It is going to be extremely important to plan your refactor to be incremental. I guess there's a couple major reasons, but the refactoring is dangerous in the sense that you might touch a whole bunch of code and you might break things. And if you break things, it might not be clear how to unbreak them because you've touched so much code. And that might mean, this is assuming you've detected things are broken cleanly and it's very clear that things are broken. You might find that you might have to completely undo all your work and start back from scratch because you might not be able to figure out how to fix what you broke easily. I've had to do that a few times. Now, that doesn't necessarily mean you're going back to square zero because you've learned a lot along that path. So the next time you dive in, if you roll back your code to the first commit before you did the refactor and start it again, you have a clear sense of the path of how to get the code done. So you'll go a little faster second time around, but it is obviously going to be a lot of lost time. So an incremental approach is the way to go so that you make small changes that you can commit that are now working, that either there's many beneficials if you can slice your refactor up into many small steps. Is you can continue to deploy functionality in the midst of doing this refactor. You can do 10% of the refactor, commit it, deploy it, and then go do some feature work, deploy, commit those, and then do the next 10% of the refactor. It also is going to be a big deal when working with teams, which we'll talk more with in a little bit. So a couple thoughts about incremental design. Time-boxed steps, you're going to really want to sort of do stuff that can fit in, and you have to decide within your overall development structure what makes sense. But I kind of feel like a couple days of development time for one or two devs is kind of the right size chunk for these incremental steps. Modular focus. If your code is well modularized, then if you can, say you've got 5 modules, if you can focus on module 1 and 2 first and do them without doing anything that affects modules 3 through 5, that allows the rest of your team or yourself to keep working on 3 through 5 while you do these changes. And I'm going to use the concept of rolling back for each of these incremental steps, because again, that's sort of, there might be this aspect of you break things, and you might be halfway through the overall refactor, you're like 50%, you're 5 incremental steps in, all of a sudden things break. If you've been doing the refactor as one big monolithic change, you might be like, I have no idea what of all these changes broke things. But if you did steps 1, 2, 3, and 4, and each one of those checked, passed tests, and then you do 5 and things break, now you got a rollback point that's recent. You don't have to go back too far. You can roll back to there. You can use that to continue feature work. And then you can try again to do that step, that next step, and figure out why it breaks things. So incrementalism, super powerful. Last thing I want to throw in is an option to do side steps along this path. So it might not be easy to break up your refactor into multiple little steps, because it might be, changing your class hierarchy if you're doing a very OO design. And if you change your class hierarchy, there's kind of a point where you kind of have to touch everything or nothing in order to get it done. It might be hard to break things, to separate it up into incremental steps. So sometimes it can be a useful tool to not go straight from A to Z, from your destination to your source to your destination. Sometimes it can be useful in service of incrementalism to have your path zigzag a little bit along the way. So you might add code that you are planning to throw away as part of your refactoring, because in sort of my jungle explorer analogy, you might be traveling from here to your destination through the jungle, and you hit a river, and you can either try to build a bridge across that river, which is a lot of work, or you can go a half mile north to where the river is shallow and do a crossing up there and come back down. And even though you went out of your way, the overall process is going to be less overall, less effort, less overall energy, less complex. So in service of incrementalism, sometimes it can be okay to add code that you know you're going to be throwing away if that unlocks your ability to break it up into some incremental steps. So nothing wrong with writing some throwaway code. All code is throwaway at the end of the day. All code will be rewritten and thrown away and recycled eventually. If it's the fastest way to get the overall job done, don't be afraid of throwaway code. All right, so that is the high level of planning a refactor that I want to talk about. Now I'm going to talk a little bit about executing the refactor, which is kind of, again, blurred. There's a blurry line between these two things. And the first topic here is unit tests, which really just applies to any of your testing, but I am always, my favorite form of testing is unit tests in the sense of, for a module, tests of its interface against what it's supposed to do. Not test of the internal implementation, because that should be isolated. What you really care about with any module is that the clients of that module are not affected by your changes. What goes on within the module, what happens in Vegas stays in Vegas, what happens inside the module stays inside the module. I still promise to do a show on modular design. I think it's one of the most important concepts in software and does not get enough attention. But you might want to shore up your tests before you start refactoring. And that's sort of part of your planning. It also should be the initial bit of work, because you want to know when you're done with each incremental step of your refactoring and when you're done with the whole thing that you haven't broken anything. And how are you going to know if you haven't broken anything if you don't have good tests? Now you can do manual ad hoc QA testing, just running the program, testing it out, poking and prodding stuff away. We all know that that's going to miss a lot. So I highly recommend shoring up your tests, your automated tests, because you're going to want to test each incremental step and you want to test them consistently. That's what automated testing is going to do for you. And again, I would focus on testing as if you're an external client of the modules that you're refactoring or of the whole system, as well as that's relatively easy to do. Let's talk about refactoring with teams now. Whether or not you are a solo developer who wears a bunch of hats between getting your deployments working, between responding to production issues, to fixing bugs, to adding features, and of course, planning and executing this refactor, or if you're actually a team of multiple people, all of this applies to you. The challenges with refactoring in this environment where there's lots of other things that need to be happening in your code at the same time as the refactor is that refactors touch a bunch of files. And in touching a whole bunch of files, refactors create a very hard scenario for a Git to merge nicely. So just the nature of refactors tends to make things that are not very easy for Git to do a nice merge conflict resolution. And so if you've got other code activities going on, whether or not it's bug fixing or feature adding or other issues in the same files you're doing the refactor on, you're going to have very hard to manage merges between branches when you're checking in your code. So when working with teams, or just if you are yourself multitasking and doing the work as if you were a team, there's a couple thoughts. This is part of where the incremental planning is going to save your bacon, in that you can go switch over and do one incremental slice of your refactor, get it done in isolation while no one's working on anything else, and then go back to doing these other things you do, bug fixing, feature work, all that stuff. If you are literally working with the team, so it's happening simultaneously, one of the things I've done that I like is I shift my work schedule. I shift my work schedule to be either I tell the team to check everything in by the end of the day, and I will work like a 4-hour shift in the night and take that out of my day. Or perhaps I will have on Friday, for example, say everybody get everything checked in by the end of Friday, and then I will work on the weekend in order to get the refactor done, and so I can come back in the week. And if you love your work as much as you want to work. But one way you can do it sort of as a work-life integration is just swap out days, like take a couple days off during the week and move it on to the weekend so that you can work opposite your team and you can do the refactoring while they're not in the code to avoid these merge conflicts. That'll save you so much time and energy. But there's another way to do this, which is, so that's time multiplexing. You can also do modular multiplexing, which we talked about briefly before, which is, say you got 5 modules. Well, if you can make your incremental refactor, maybe it has to eventually touch all the modules, but if you can do a first step that only touches 2 of the modules, but the other 3 are completely unchanged, and the external interface for these 2 is unchanged, so these don't need to be touched at all, your team can be working on bugs and features on these other modules while you refactor these literally same day overlapping. And so you do that in phase 1, and then maybe the next phase is these 2, and then maybe it's these 3, and maybe it's these 2, and eventually everything gets refactored. But at every step of the way, some of the code is non-overlapping and can be worked on while you're doing the refactoring. So there's a few strategies for refactoring with your team. Otherwise, mostly you're going to make these edits and you're going to run the tests on them. That's sort of the execution aspect. You've done list planning, you've thought through the steps, you know where you're going, you have come up with an incremental plan. Now you just pretty much execute it and run your unit tests regularly, right? So you want to make sure that you're not breaking things so that you have good rollback points. Check in often. I guess I didn't touch on that. I am a huge advocate of checking into Git all the time. Like I try to check in 10 or 20 times a day so that I have as many incremental rollback points as possible when things break. One other thing that's really powerful about that is if you check in maybe 20 times in a day and all of a sudden you discover at the end of the day something broke and it wasn't just your recent change, it was something you did throughout the day. I use bisection with my Git commits to find a solution. So I'll jump back 10 commits, run the test. Does it fail or succeed? Well, if it succeeds, then I know it's after. So I'll jump forward 5 commits. So that's 15 commits in, test there. Or if it fails, then I'll jump back 5 commits to the first 5 commits of the day. And so you can do bisection on your Git history to find out where exactly it failed until you get to the point where you see one commit. This commit is the commit that broke it. And if your commits are small, and often, bisection of your commits is a very powerful way to figure out where things broke. And once you figure that out, then you should have a pretty good idea how to fix it and keep moving forward. All right, we're almost done. The last thing I want to do is touch on just a few refactor fails. Ways your refactor can go wrong. First one is just long running. Once you're going to do a refactor, you really want to commit to getting it done. If it is long running, there's so many ways it can fail if it's long running. And long running, I would say, would be more than a month. You should sort of time box your refactor to be no more than a month. Because one, that if your greenfield target, you set your greenfield target, figure where you need to go, within a few months, that greenfield target will have changed. Like you will have more information, new ideas, where you should go to has shifted. And so your refactor will have drift. And drift will result in a muddled worst of both worlds. It won't be good for the new destination. It won't be good for the old destination. Also, there's just if you just let it keep going, then it might just not have the right level of priority and you might not get to it, might not get it done. So try to time box it and try to prioritize it. Once you've committed to doing it, do it as quickly as possible and get it done. And that requires focus time. So I think that you just really need to allocate. It's going to take some focus time. We talked about some time multiplexing tricks just a moment ago. Long running branches, same thing, which is why the incrementalism helps you, but that's a place where I think I've seen most refactors fail. It's where most of my refactors have failed, is I get really deep on a long running branch and it gets to the point where it is very different from the source material, but I need to go back and add features to the source material because I need to deploy stuff. I add features there, and now all of a sudden I can't merge the two. Merge conflicts get out of control. And, well, I got to keep the features that are deployed. That's what ends up winning. And then I basically have to roll back my refactor and start scratch, start from new again. And so that has been an ongoing learning of mine. The broken code scenario, which we talked about, another aspect of incrementalism, is if you get halfway through a big refactor and things break, and you have no idea where, and the only check-in point that you have that's good is way back at the beginning of halfway through the refactor, then you might have to roll back your whole refactor because you just don't know how to fix. Fixing the refactor becomes so onerous that it's probably cost less to roll back to the start and start again. But if you've got incremental steps, which again, an incremental step means fully deployable, pass all tests, good to go test. What I'm talking about is when you don't have incremental tests, you get halfway through and it's not a functioning piece of code. Like maybe parts work, but some parts do not work. Some parts are in a in-between broken state. That's what I mean by no incremental steps, is when there's no point where it's deployable again until you get to the end of it. And I think that covers a lot of it. Again, that's sort of that merge conflict with other branches, not having enough focus time, so your purpose gets muddled and you don't really stay focused on getting it done quickly, and your target keeps moving, so you got a moving goalpost. Those are ways that it fails. Not doing it incrementally, those are the refactor fails. So back to the high level. Overall, we're talking about how to plan and manage a refactor. We talked about keeping a shortcomings log. Start doing that. Just log anytime anything's not what it should be, and that will give you the structure for planning, for thinking about what refactors are worth doing, because you'll have evidence. Literally, you'll have evidence about what is problematic and how you can solve it. Refactor plan, start with a greenfield design. It's super important to ignore the current implementation, otherwise you're hamstringing your ability to get the most out of this refactor. And then come up with a pragmatic approach for how can you get from here to there, and make it incremental. Can't emphasize enough, making it incremental is going to make this refactor much more successful, in that each step of the way you're making progress. It's deployable, fully working, so you have good rollback points. You can time multiplex with other things you need to do, like feature deployments. And it's just going to make life a lot easier. Also, if you can do it modular multiplexed, in terms of only doing a couple modules at a time and leaving the others untouched, allows you to work on those other modules in terms of features and other deployments while you're in the middle of doing the refactor. When you're executing, the first thing you want to do is beef up your unit tests, particularly from the external interface, because that's when you'll make sure that the whole point of the refactor is not to change the external experience. So, and having automated tests to validate that's going to save you so much time, because if you're breaking it up into 10 steps, you need to validate each of those 10 steps along the way and make sure that they're working. You want to do that in a consistent, reliable way. So beef up your external UX, interface, API probably, unit tests. When you're refactoring with teams, again, you want to multiplex either in space across your modules or in time, so that your team can be working on different files from the files that you're currently touching. And so if you're working on modular multiplex, you work on 2 of the modules and they're working on the other 3. And when you're done with that refactor, you check it in. And only once you're done there, then allow them to touch those again. Or you time multiplex, say, end of the week on end of day Friday, everybody must have all of their current branches checked in and merged into develop. And then I'm going to go in and do the refactor of the weekend. And then you come back on Monday and you can check out new branches and move forward. Because you do not want to try to merge feature branches with refactor branches. It's a nightmare. It's a nightmare field. Don't do it. Which leads me to the refactoring fails, which we just covered a moment ago. Stay focused, get it done quickly, be incremental, and don't, like I just said, don't try to merge your feature branches with don't have other work going on in the same files that you're doing refactoring. So that's the high level. That is how to plan and execute and manage a successful refactor. I look forward to talking to you more about refactoring and how you design your code in the first place to be easy to refactor. Super important. That will have to wait till another episode. Until then, I want to say thank you so much for spending your valuable time with me. I very much appreciate your time is valuable, and I know it takes some time to go through these. I enjoy making them. I hope you get something useful out of them. And remember, all problems are solvable with enough knowledge.